Hi everyone, today I'll be going through an intuitive approach into understanding the algebraic properties of dot product. Now in dot product, there are some properties that might seem relatively simple but actually aren't that simple. And there are some properties that also seem very hard but actually isn't that hard. And when I go through, you'll see what I mean. So let's get the first property. A dot B equals to B dot A. Why is this the case? So let us use the formula first. What is A dot B? A dot B is mod A mod B cosine theta. Then when you mod something, right? When you mod something, it becomes scalar already. So mod A mod B, if it becomes scalar, right? Then it gives us the freedom to switch it around. So I can switch the B around with the A. Okay? Because we already make it a scalar quantity, so you can switch it around. After switching it around, we get mod B mod A cosine theta, then we get B dot A. Now let's get 2. A dot A equals A squared. Now A squared, looks so complicated. What is this? Actually, it's the same. We apply the same formula. A dot B equals to mod A mod B cosine theta. It's the same. But we apply it for A. So mod A cosine theta. Then what is theta? Theta is the angle between two vectors. Okay? The angle between two vectors. So this A, B. Then the angle between two vectors, but what's the angle between A and A? Angle between A and A is 0 degrees. So what is cosine 0 degrees? Cosine 0 degrees is just 1. So A and A, they are scalar products. Multiply them together, they get mod A square. Multiply by 1, you just get A square. Let's look at the third property. Third property, we have lambda A dot mu B equals to lambda mu A dot B. Why is this the case? Same. Apply the same formula. Okay. This formula is very powerful. It allows us to derive a lot of properties. So apply the same formula. So you get lambda A mod not mu B cosine theta. Then since it becomes a scalar product, then for scalar products we know that like K A just equals to K mod A. So you can just take out the K can be lambda, can be mu. So we can just take out the lambda, I take out the mu. Then I put them together, lambda mu mod A mod B cosine theta. Then mod A mod B cosine theta equals A dot B. Then lambda mu dot B. Here you go. Then look at 4. This one, right, seems so simple. So simple, right? This one, secondary school, little children also know how to solve. You rainbow method here, then you get the answer, right? Right? Ha 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 ha. But no, vectors isn't that simple. Okay, so why is this the case? So I will show you what's the actual mathematical reasoning behind this. Okay? So I'll first let A be x, y, z. So ax, ay, az. Then same for B, right? x, y, z, then A dot B plus C. Apply the same formula. Let me tell you, this formula is so powerful, okay? So powerful. Alright, apply the formula, then you get using the scalar product, then you like this dot, right? Boom, 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 boom. Okay? Wait, you actually don't apply a formula. Wait, okay, you just do it normally, sorry. So you just do it normally, right? Do it normally, you get like this, right? You dot product it, then you get something like this. Then you rearrange it, right? Then you get something like this. Then what is this? What is ax, bx, ay, by, az, bz? It's just this. Okay, now what is this? This one is just this also. It's just this together also. Then this ax, ay, az, bx, by, bz, ax, ay, az, cx, cy, cz. Just a dot b, a dot c lah. See? So this is actually the mathematical reasoning behind this, okay? So it's not just rainbow method, okay? These are vectors. We cannot just anyhow rainbow them together, okay? And let's look at the sixth property. So if the theta is between 0 degrees and 90 degrees, which is acute, then A dot B is more than or equals to 0. Or if theta is between 0 degrees, this should be 90 degrees. Okay, 90 degrees or 180 degrees, then A dot B is less than 0. Why is this the case? Okay, so this one, right, we need to get cosine theta. Cosine theta, ASTC. ASTC, we learned from secondary school. So where is the quadrant positive? Quadrant positive for cosine theta is the first quadrant. First quadrant positive for everything. Then second quadrant is the cosine theta positive or negative? Negative. So if theta is in between 90 degrees with obtuse, it will be negative. So the A dot B will also be negative. Okay, let's look at back the formula. See, A dot B equals to mod A mod B cosine theta. So if cosine theta is negative, A dot B is negative. Okay, then the same logic applies for when the theta is acute. And this is an intuitive approach into understanding algebraic properties of dot products.